Okay, I'm back. Um, there were some streaming issues this morning. So I restarted the Mac, and I'm trying to stream now, see if it actually starts dropping frames again. Um, I was actually gonna basically restart the whole stream from the beginning since it was dropping out a bit, and it wasn't up to what I normally do. So I'm gonna restart the stream and see if it starts dropping out again. I restarted the PC. I don't think it has anything, or the Mac. It didn't. Don't think it really did anything. I close off all the apps and stuff like that. See what's gonna do. Um, anyway, so let me just get the guys back in. Yeah, let me know if you guys are back in so I can start talking again. Open up the frame again. Check. Oh, looks like we are back. Okay, so like I was saying, I guess I'll start from the beginning again because I was dropping out on frames. So this is the new sort of work in progress for the wine cooler. As John said, um, the major changes that were made was basically moving from a 750 millimeter tall to 1000 millimeter tall, so 1 meter tall um, vertical members, which gave room for on top of the printer to allow the Bolden tube to travel freely from the extruder to the hot end. That was something that I didn't need the space, the clearance for in the open frame design. So on an enclosure, because you have to have a roof on the enclosure, it wasn't taken into consideration. So the change was made so that we got about 290, I think, or 310, something in that range, about 300 millimeter vertical space here for the bowling tube to travel in while it's within the enclosure. Um, the top the top frame is the top frame is basically designed like a house window with two panes, the front and back, and a cross member in the middle. So the oh, crap, really? Okay, you know what? Give me 1 second. Let me see who's upstairs streaming. Hang on. Okay, let's see if that works any better. My dad was watching some streaming upstairs, and hopefully that solves it. So, what was I saying? Oh, so the uh, the cross frame, the cross beam on the frame is designed for two purposes. One is so that a huge piece, like 500 millimeter square Lexan, doesn't concave under the gravity, so that it basically it's only doing a 250 millimeter span on either side. And the other thing is the cross beam allows mounting of possible mounting of extruders. So the idea is that instead of having a long Bolden tube travel over into the enclosure, is to mount the actual extruders inside the enclosure itself, so that it minimizes the bolt tube length. And if we kind of position the extruders in the middle, it allows to travel on all the entire bed, and the bolt tube will be as short as possible. Donald was asking, the other request was that maybe we could mount multiple extruders for multiple extrusions. So this is 500mm span, so it allows us to mount those and a bunch of other stuff, like if you wanted to mount a webcam so that it take time lapses from the top. You could mount LEDs into the groove so that it faces downward. It lights up the printed area, so on. You get the possibilities are kind of endless. You have 500mm of extrusion on all sides to sort of do whatever you need to do. Maybe you can hang the controller or whatever you want to do, hang off over there. So it seems like, knock on wood, the stream is going well. So I think it's just that my dad was watching something upstairs. He's feeling way better. He went fishing the other day, just in case anybody's wondering. Came back with a few fish, so he was happy. So I think he's recovering well. Anyway, so this is the top, and the way that we actually attach it to the frame is actually took a little thinking outside the box. So basically, what happens is that this extrusion is bolted down into the rest of the printer. It provides a mounting point for the front fascia to mount into it, and that happens on all four corners. So you can imagine you mount the two forward and backward extrusions. It provides 4 holes, and then because this bolt is in the way, you could tell from here, you could see this bolt's in the way. Sorry, this bolt's in the way. You can't use that other hole, but all you need is 2 holes for the whole front fascia to mount onto the frame. What that allows you to do is actually mount these 2 left and right pieces and the cross beam, and then slide in the pane, and then close off with the front fascia, and the same in the back. So it's actually it works pretty well, and I thought like the design was simple and it worked pretty well. One thing that we have to do is, because there's no, this piece is able to rotate in place. I have it. We need to use these FaceTime. We need to use these simple metal brackets right here, so that right here, so that it would bolt, it would hold it in place so that it doesn't rotate on the axis there. So yeah, that should work pretty good, because I double checked it and make sure that it works. So one thing nice about these brackets is that look at FaceTime again. Let's see if I can get it so you can see it. These brackets are designed so that you could go on the edge like that to hang it off of it, as well as on top. So these Masumi brackets are actually dual use. Not sure if T-Sun would get it, but like it would work about the same way. So we should be fine with that. Hey, so far so good. So I guess next time when I stream, I gotta tell my dad not to watch TV. What else can I do? Let's go back to. We were talking about the alignment tool. So I was able to make a quick edit, so to show what I was talking about. So basically, this piece is the 22mm spacer I was telling you about, that basically bolts from the edge, and you would bolt it down so that it would give you the clearance you need for the motor mount. Because I mentioned on the The motor mount is not the motor mount. The idler mount is only held in place by the vertical extrusion. So on the horizontal, there's nothing holding it. So it allows it to sort of slide. So when you mount it, it doesn't, it's not locked on by the alignment block. So what that means is that it's hard to use that as a spacer to see where your rail starts. So the idea is that this block gives you the that 22 millimeter spacing you need. The other thing is the I can get this side profile here and get rid of this. So what this block is basically there's a bunch of resonance from the printer. It slides along the extrusion and aligns the rail so that it's centered on the extrusion itself. Because that was one concern, was how do we make sure that you have equal spacing along the entire length of the rail. And what this has actually has access holes on top, but that's spaced the same way as the rail. So the idea is that you would bolt down one end of the rail snug but not tight, and then you would, let me change this, like you would bolt one rail tight, and then what you do is you would then slide along that guide along here, and then as each intersection of the bolt, you would start bolting it down all the way to the end of the rail. Then you will slide it back and work your way back again to make sure that when you tighten it, you're using that alignment tool to make sure that it's centered on the rail itself. By using the same block, even if you have variances, you would have the same variance on all your XY on all your XY rails, so that the variance kind of cancels itself out if you have the same variance all over, right? So that's the idea of that tool. So I'm going to print these out next so that I can start on assembling one of the rails and see if the idea actually works. So let me see if I can show. Like, see, these three holes are spaced 30 millimeter apart, and these three access holes are 6 millimeter holes that allow you to sort of drop in a M3 bolt and then sort of slide along it and tighten it as you go along. So that's the other thing is the rail itself uses 3 millimeter bolts. And so then it means that you're gonna have to get 3 millimeter T-nuts. Let's see, get the focus on here. There you go, 3 millimeter T-nuts, so that it would hold a rail in place. So these are same size as the M6 nuts, except the M3. So you get 3, 4, 5, and 6 on these. So these are 3s. Originally we were going to use some M4s for the tensioner, but we don't need the tensioner now because we use the motor mount to do the tensioning. So we should be pretty good on that. So that means there's only 2 kinds of T-nuts: the M6, which is the normal ones that we normally use, and you need about, I would guesstimate about 40 of these for the rails. So yeah, it's gonna get another pack of these, and then you probably end up with using half of it. Comes in a pack of 100 or singles. It's gonna cheaper to get a pack of 100 and split it with somebody if you need to. I took some pictures, but it really doesn't do like video doesn't do this thing justice. Like look how shiny this thing is. Got my fingerprints all over it already, but the idea is that it's a milled surface for the rail to sit on. So one of the concerns was that the the extrusion was not perfectly flat, and people had issues mounting the rails to this. So there's also the I would consider hacks where they actually cut this whole thing out and lay the rail right inside the extrusion, which I thought wasn't really that good. The other thing is they had people mounting plates on top of this that was a milled surface. So it's kind of like redundant, right? Because if you could mill this surface to be flat, why mount the plate then mill it? So it's kind of like double the work. So Misumi was able to mill that to like this mirror finish, and checking the flatness of it was pretty good. So I'm pretty happy with that. Well, that print's done. Let's just have a look. Yeah, that's the dark jade that John is using on his Haribo 3030. I decided that was a good color, so I'm going to use that. I'll let that cool down and take it off the plate and see how well it mounts on the on here. So the these are actually high rigidity. You guys know how I like using high rigidity extrusions. These things are like built like a tank, so when you mill it, like you have so much meat to take, like to cut into, that I think it's gonna work well as the surface. What's nice is that they did, like you pick the they do both sides. So when they do the milling, they mill the parallel sides. So there's two sides that's not milled and the two sides that are milled. This side is used for the rails. The bottom is actually used for the rod mount. So the rod mount will have a very flat surface to mount onto. Hopefully I get to that, assembling that axis today, so that you see the rail being mounted onto the extrusion today. What else did I get? Oh, so I don't know if I could do this. Let's try this. I'll pick up the camera and let's go this way. So that is 750 millimeters. So if we compare that to the Haribo, is basically as tall as the Haribo with the spool in it. That's how much the how tall that vertical member is going to be. So this 750 millimeter tall. Again, I went with height, rigidity. So yeah, this thing ain't going anywhere. So the idea is that this end is the top, and we have bolt holes for the bottom, so that basically I'm going to use regular non-milled on the bottom, and then the 4 top ones would be milled. So then there'd be four cross members on top, 4 cross members on the bottom, and I can actually get the whole frame up and running, like looking like a printer this week. So got these yesterday, and they were like, yeah, tough as nails. You really can't, like, I don't think you're really gonna be able to shake this thing once it's done. So that's what's back here, I guess. If you guys see that now, it's back here. I was just unpacking it. Yeah, it came in. It came in from Japan, landed in Chicago, and then let's get this adjusted. Landed in Chicago and came across Detroit, Windsor, and then came on a truck. So package was like this big. So I'm gonna also order the extrusions for the enclosure build because I want to make sure that there's clearance and everything for it. And I'm gonna see if there's a way to adapt the spool idea, the spool hold idea, to place the extruder in the same spot as if it was enclosure. So that basically is going to be suspended on top of the XY, so that it would use the same shortened Bolden setup versus a loop-de-loop into the top. Because I sort of want to keep at least the mechanisms or the kinematics the same, so that even the Bolden routing the same, so that we don't have a discrepancy on the settings and firmware. Because I could, on an open frame, normally what you do is you mount it on the side profile, and then you would just fly it across. But that means that the tube's going to be at least twice as long as if in the enclosure edition, which is the extruder being on top, is coming straight down. So then your retraction settings and your basically the majority of the retraction setting would be different. And the other thing is that if we wanted to, for the open frame guys, if they wanted to sort of go with multi-extrusion, they really can't, because it's hard. Multi-extrusion with long Bolden tube is hard. So that's another consideration. Trying to see if I had brought something else down to show you guys, but I think I misplaced it somewhere. Hang on, let me go get it. So this is that thing I was telling you guys about, the 2-in, 1-out hot end. So basically, it uses the E3D style heat block and nozzles and heat brick. And the idea is that internally here, there's 2 paths for the filament to enter, and depending on which one is being pushed at the time is what comes out of the nozzle. So I'm going to try to see if we could get this to work with to do dual extrusion. So the size wise, I mean, is pretty comparable to an E3D setup. Has a flat mounting surface, so we have to figure out how to get this on the spider. Cooling fan for heat brick, heat sink is kind of the same, so probably could use like a Natura one, so that it's a little bit more silent. I haven't even fired this up yet, but it looks pretty good. It uses the same hot end, so I'm gonna try to see if I get that on as the kind of the optional hot end. I think the reference is still going to be E3D V6, just to kind of be standardized across the printers, and then for the multi extrusion we could kind of play around with different setups. Yeah, it looks like it was the streaming upstairs that was causing the drop frame, so looks like it's fine now. Oh, and that was the other thing. We got the new plates, so they're slightly longer. Like lengthwise, they were slightly longer, so that they cover up the T-nuts when it gets mounted. So I got a new one. Thanks to Otto, got the new plate in the mail, so it looked pretty good. So last few weeks I got a bunch of eSun PTG because Filament.ca was out of stock. and they had the eSun stuff on sale. It prints okay. It's not exactly like the best filament out there for the price. I mean, it was $30 odd. The like 28.99 snow pesos, and I just got a few rolls just because I was running out of PTG in different colors, and this is the stuff, and it didn't really print well. Didn't really like it. The film SCA, I think, still my go-to filament. I printed some stuff for Roger. I think Roger was the one who bought the uh, Haribo parts for me. I printed the XNs and sent it to him, and they came out perfect. So the dark red actually was a bit hard to get from Film SCA for some reason. I guess it's a popular color. Um, so yeah, I got that resolved because I owed him those parts and I sent it out to him, so he's happy with that. Um, so plans this weekend, because it's a long weekend for me. So the plans this weekend, one is to get at least one of these linear rails mounted, and then make sure that everything works the way I visualize it in Fusion 360. Then finish all four, mount them onto the frame, get the frame actually looking like a printer, and then print out the Z wrap mount and make sure that the idea works. And then I would need to print alignment tools and spaces there as well, because let me bring it up. Let me have a look. So the distance between this and the edge here is roughly 120 millimeters. I remember, that's the one I remember. Let's just measure it out, see what that works out to. Yeah, 120. So let me bring this down here so you guys see it. So it's like 120 millimeters. So what I wanted to do was print another part that basically sticks on into the groove, and will align 120 millimeters so that you can sort of just bolt that on and it'd be correct. Then you use the same jig on all four rod holders, so that again, like, any variations in the print will be on all four corners, so you don't have this issue with not being parallel, because you would then also use the same jig on top, because all of these I model all of these to be 60 millimeter wide on purpose, even though they're overkill, because I think on the Voron they use like the one nut to kind of go into the top extrusion, but to get two nuts in, I need a 60 millimeter. The reason why I did that was all because I could use the same jig to align the top and the bottom, so that the rod hole would be the same, because the rod hole is also printed on the same orientation. So any variances on your printer is also taken into consideration when you print this the way it sits. Like, the way you see it is the way you're supposed to print it, and then same with the bottom is the way you're supposed to print it. So any deviation in XY for your printer is just going to show up here, and it's going to cancel itself out. So that's the idea with that. And then we would have sort of like a mini jig between the, like, you would sort of, I'm not sure about this part yet. So the motor mount is still debatable, because one thing I didn't like was the fact that it came almost down to the bottom of that extrusion. So I was going to use this slot here for the what can I say? I was going to use that slot there for the bottom floor, if anybody wanted to put a floor on the extrusion, so on the enclosure. So that mold is blocking it. So the other thing is, I think getting this is 500mm lead screw, 8mm diameter. That's kind of pushing the limit of 8mm. Even though it's not a structural piece, it's still going to flex a bit. So, and I have to use two of them. So one thing I wanted to kind of get into, which I guess I could sort of show you guys now, is let's minimize this and let me see what it's the idea of belted lead screw drive. So that's what this is. It's basically maybe get a full screen of this. So the idea is that you have one motor that runs two belts, and the two belts connect the two lead screws that moves the Z platform. They're supposed to solve two problems. One is the synchronization of the two Z motors, so then you could use one big NEMA 17 to drive both sides versus using two low profile ones and then doing a series of parallel and sort of go and try to synchronize them to lift the platform. But this basically, with the belts linking all three by pulleys, is basically you're guaranteeing that they will run in step. So it's double belted because there's space. I'm thinking about using a thicker belt, like a 10mm belt instead of the 6mm that we normally get. And you can probably get away with just using one pulley on all these to make the blocks a little bit low profile. It doesn't really show well here, but there's a pillow block on top. Let's see this one. There's a pillow block on top and a pillow block on the bottom. You can see it in the far picture there. There's a pillow block on the bottom. So what that is there's set screws in the pillow mount, and it captures the lead screw so that it would turn inside the. There's a bearing inside. It turns there. So the idea is that you use one top, one bottom, and that will let's see. That will allow the alignment of it being straight, because basically if it captures it correctly and your top and bottom is printed on the same plane, then it should not tilt. It should basically be perfectly up and down on the to hold the Z axis. And the other thing is that they do that because they want to go to a 10mm lead screw. So a 10mm lead screw by itself is going to be a lot beefier than a 8mm. So I think that if I could somehow incorporate this into the design, I think it would work well. So this is the next thing on the list to work on after the Spider is getting this motor mount with the belt drive going to finalize the Z movement. So as long as I get the Z movement going up and down with the lead screws, then I can move on to the bed mounts. Because right now it's sort of like critical path where each thing depends on the previous step. So kind of have to deal with the Z motor mounts and then kind of get that out of the way. The side effect of this is that we're no longer constrained by which NEMA 17 motor can we get that has the lead screw that we want. The NEMA 17 motor is going to be generic. In this case, basically any motor that you're going to be able to drive the two sides with is going to be good for this purpose. And then the lead screws that is not integrated into a motor is fairly cheap. I think I found one for $20 odd shipped from AliExpress. If you get them direct from, I guess, I'm assuming they're about $35 US each. So we only need two. So $70–80 for two from Masumi, or I guess, or like $30–40 for two from AliExpress. So it's really toss up between the two. But the idea is there. You did the belt drive. One thing is I have to figure out is there enough offset for the bed so that when it comes down, it doesn't hit the motor. So it's one of those things I have to check to see that the way I'm mounting this motor is going to work. I may have to kind of flip this around. That's why I wanted to see if I could use a single pulley. Then I could have more vertical clearance with a single pulley. So this one actually, this is off of Voron. So you could see what I was talking about with the rod mount. They use, this is a 10 mil rod, I think. Yeah, I'm pretty sure it's a 10 mil rod. They use a single screw that goes into the extrusion here, and in the printed piece there's a slight indentation to capture the profile of the extrusion into the printed piece to align it. That'll work, but now your whole entire platform is held into the extrusion with one bolt on each corner. For me, is I wanted to over-engineer it and gonna go with 2 bolts per corner, up and down, so top and bottom, so that I know that that rod isn't going anywhere, because the rod is what governs the vertical movement of your platform. So that's kind of critical. I want to make sure that that works well, and then it will get captured. What I was going to talk about. I think Bondtech. I found the Bondtech one before. I think I showed you guys before. So I'm gonna be ordering one of these Bondtech extruders so that I could test fit it onto that vertical cross member to see if it clears it. If it clears it, then this will be a good extruder to use for the cube. It's either this one or we go with something like the Titan, I think. The problem with the Titan is I think it's a direct drive, and I don't think it works with the it wasn't Titan. What's the other one? Oh, I remember. I had a brain fart there for a second. CNC, right? Yeah. Not Titan. I was thinking Titan, but the Easy Extruder. That's what it was. So I had an Easy Extruder on my Delta, and it was probably one of the easiest. That's the new version. That's the Easy Extruder 2. So let me go to this site. I have better pictures than Google. Of course, it's not good. Yeah. We really need to. Yeah, so that it's a rendering, but it gets the idea across. This is the new version of the Easy Extruder. Basically, it bolts onto your NEMA 17 motor. This red part is the tensioner for to grip the filament, and they give you a blue knob so you can actually manually feed the filament if you need to, and then basically has a bolt-in adapter. So you could use this for both direct drive and like with a short tube direct drive, or you could do it in a bolt-in setup. So looking at this one as well, because it's fairly cheap and it's made in the US. So and they have the 2-in-1 filament guide. So this is kind of like a same idea, right? What you do is you would pull back on one bolt-in, and then you would feed in the other. So as long as your first retraction retracts cleanly, then your next extrusion is gonna change the color. So back and forth they go, and it seems to work fine, but they still kind of in beta for that. But it's a cheap hack, $19 for that. So this is the old one. So again, I'll show you guys. This is the old one I was using. Has the bolt-in adapter, and same idea. It grips filament really well. And I used it on the Delta, and it was one of the better extruders I found. So really consider using that as well. So the nice thing about the way that the cube is set up is it's not really tied to one extruder or the other. Is the spider is going to be bolted, so how you feed that bolting is up to you, right? So there's options, but again, I'm probably talking about 5, 6, 7 steps ahead of where we need to be. The um, main goal right now is going to be to get the Z all panned out so that the firmware could be modified. So to run with the XYZ, do some speed tests, movement tests, make sure that we don't have any gotchas in the beginning, then move on to the hot end extruder and so on, because that's kind of like the tail end of the project at that point, to get the alpha, and then we could kind of sort it out. The for the enclosed, that's for the open frame. For the enclosed edition, let's go back to FaceTime. Sorry. So for the enclosed edition, we kind of have to work backwards. We're gonna have to somehow make the overhead, I guess I call it gangway or overhead bridge for the extruder mount for the open frame. Get the extruder mounted and running with that. Then figure out what is the height that I need to get that to work. And then adjust the vertical members of the enclosure to that same height. Then we could finish up the enclosed edition. So the open frame will need to be constructed first. Test it with the bolting setup, sort out any issues with the bolting moving, like maybe at acute angles it bends too much or whatever it is. Get all of that sorted out, and then adjust the height of where the extruder needs to be. Finalize that, then port it back into the enclosure design. So I know Donald wants his enclosed. I'm going to build an open frame, and hopefully Pat up in not Ottawa is going to have some time left in summer to help me out with this, with the firmware. Let's see how it goes. I think if I don't get volunteers, I end up doing it. It should be okay. So I think with the restart everything, we're up to 45 minutes. So I'll take any questions, concerns, answers, suggestions, blah 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 blah. Not just about the cube, but anything else, like about the 3030. We talk about that too. I didn't get a chance to. I'm still sitting on it. The multi-material upgrade. I got that like 2 weeks ago, and I haven't installed it yet because I don't want to kind of take apart the printer that works. This one needs a little work, so I might take it apart and do that. Yeah. So let me go back and look at the chat for a sec. Yeah, the stream is running well with my dad watching TV upstairs. So I guess the streaming kind of clogged the upload. So now it seems to work fine. I'll keep that in mind, because basically what I do is I end up like Saturday morning I'll do this a little earlier so that it's before he starts watching TV, and then Wednesday night I could go a little later because he will be sleeping by the time I start streaming. So hopefully that works out. Like I said, just to recap, the goals this weekend is to print the alignment tools, start on the rail mount the rails, get everything kind of sorted out, build the exo frame, the skeleton of the open frame, um, get it so that it looks like a printer, and then start to um, mount the rods for the Z mounts, the Z rods, kind of start measuring where they need to be, make the spaces for that, get the Z looking like a Z axis, work on the spider, because I need the spider to link the XY together to move, and then yeah, then I guess we'll be halfway to a printer. Then the rest of it is just the platform, which I still have to work on, and then the extruder mount, the flyover gangway for the open frame. Um, the nice thing about that is the weight of the extruders and stuff like that is not that much, so I should be able to get away with having like a elevated pillar and halfway across to sort of for the testing to kind of hang off the extruder, and then once I figure out the exact height I need, then I could make a bridge across the two sides. I'll probably end up making some sort of 3060 so that I could use it also as a spool holder, because I sort of want the spool right about where the extruder is going to be, so it's not pulling filament across the room to get to where it needs to go. So yeah, it'd be interesting. Like once I get the frame built, I think you could kind of get an idea how big this thing is going to be, and then we go from there. So I think I'm going to end it here. It's been, like I said, now it's closing an hour, so I'll catch up with you guys later in the chat. Okay?